Good morning, everyone. So today we'll look at supplement to the problem 3 from IMO 1960. Okay, we have already seen a solution to this in the last video using coordinate geometry. So in this one, we'll see a synthetic solution to this problem, and I think it's important that you take some time and study this solution because it has certain concepts which are useful and which occur very frequently. Okay. So there is a triangle ABC, right angled at A, and the hypotenuse is BC, length is A, and the hypotenuse is divided into n equal parts, where n is odd. And it says alpha be the acute angle subtending from A, that the segment which contains the midpoint of the hypotenuse. So if the midpoint is O and PQ is the segment which contains this midpoint, then the angle that PQ subtends here is alpha. So this angle is alpha. And says h is the altitude. So altitude to the hypotenuse. So this, and then it's asking you to prove this relation. So from the first look of it, it looks less of a typical geometry problem, but more of a trigonometric problem. You know, you have to prove something related to tan alpha. Okay, so it's difficult to sort of imagine that it can have a synthetic solution. So let's see. One of the things where h is useful is to find the area. Okay, so base into height will give you the area, double of area. Okay, so if you look at the area of this triangle, so we try to calculate it using two different ways. Okay, and that's where we will end up with this relation. So first is just the area of this triangle is just half into PQ into H, right? So you can write twice the area is PQ into H, and PQ is, the segment is divided into n parts, n equal parts. So each segment is A by n. Okay, so PQ is A by n, H is H. So 2 delta is AH by n. And you can now also calculate the area in a different way. So you drop a perpendicular from this. Okay, PR, a perpendicular. So now the area will be, this becomes the base, this becomes the height. So 2 delta you can write it as AQ into PR. Okay, and PR, now the tan alpha will also come in. Tan alpha is PR by AR. Okay, so you can write PR as AR tan alpha. So we already have tan alpha here, and now let's try to simplify the other part. AQ into AR. AQ into AR. So how do you calculate this? So you notice that this is perpendicular. So if this is perpendicular, this point R will lie on a circle with PQ as diameter. Okay, so R basically lies on this semicircle. Okay, so if you draw a tangent to this circle from point A, so then this AT square is equal to AR into AQ, right? So this AQ into AR, now it becomes AT square. And now how do you calculate it? Calculate this value, AT square. So the way to do it is you join A and T with O. And this is a right triangle, so AT square is AO square minus OT square, right? And now you know the value of OT is just OQ, which is half of PQ. Okay, and what is OA? So notice that this is also a right angle, so that means this point A, it lies on the circle with has BC as diameter. So A lies on this circle, right? And this is the center of the circle. So what is AO? It is the radius of the circle, right? So that means this AO will equal OB and it will equal OC. So AO equals OB and OC, and both of them are equal to what? So BC is equal to A, so the radius is A by 2, Okay, so AO equals A by 2. And this is equal to what? This whole thing is equal to A by N. So OQ is A by 2N. So OT is also A by 2N. So this is A by 2. This is A by 2N. That's it. And this is equal to the 2 delta. So this is equal to AH by N. You query it and you just simplify it and you get your answer. Okay, so this is a nice solution. You please work it out on your own and just understand the 2 or 3 small concepts which have been used here, and it occurs very frequently in many places. So yeah, so that was what I had to say. And apart from that, thanks for watching. And if you have anything to say, you can email me or you can write it in the comment section. So thank you very much, and I'll see you next time. Okay, bye.